To begin, we will place our liquid mixture containing an acid, a base, and a neutral dissolved in dichloromethane into a beaker. We will now add a base to this mixture. Adding a base to our mixture will remove a hydrogen from the carboxylic acid, producing a conjugate base and water. To mix all the compounds within the organic mixture as well as the newly added base, swirl the beaker. Using a liquid funnel, pour the mixed solution into a separatory funnel or set funnel. 2 layers should be noticed, as you can see here in the picture. Due to differences in densities, on the bottom we have the organic layer containing the base and neutral compounds with the higher density, and on the top is the conjugate base of the organic acid and water, forming our water layer. The line separating the 2 layers is referred to as the interface. Using the stopcock on the set funnel, drain the bottom organic layer into a beaker. Close the stopcock immediately after the interface has entered the stopcock to ensure it is not left in the conjugate base of the acid. It is important in all stages of the extractions that the interface is not present in the compound wanting to be isolated, as it is a mixture of compounds and can affect purity. From the top of the set funnel, pour out the conjugate base of the acid into a new beaker. We highly suggest labeling your beakers to ensure no compounds get mixed up. Do this entire extraction process twice, beginning with adding a second portion of the basic compound to the organic layer solution. You can combine the conjugate base of organic acid from the second extraction that was collected during the first extraction. Extraction of the basic compound from the mixture is very similar to the process of the acidic extraction. We will use the organic layer obtained from the acidic extraction to obtain the basic compound. The organic layer now contains the organic base and neutral compounds. This mixture should be mixed with a strong acid, resulting in the base accepting a hydrogen atom and becoming a conjugate acid and water. This mixture should then be swirled and poured into the set funnel. Now the top water layer contains the conjugate acid of the organic base and water, and the bottom contains the neutral compound. The stopcock of the set funnel should be opened and the liquid should run out until the interface has just passed through. The liquid remaining in the set funnel should be poured into a beaker and labeled as the conjugate acid of the base. The new organic layer should be treated with another portion of acid, mixed, and returned to the set funnel. Again, the bottom layer with the interface should be drained out of the funnel, and the top layer should be added into the beaker containing the conjugate acid.
After extraction of the basic compound, we are left with this organic mixture containing the last compound to be separated. We will wash it by mixing in distilled water and running the mixture through the set funnel, producing the final organic layer. When this organic layer is being collected, the stopcock of the separatory funnel should be closed before the interface is able to flow out. We then dry the mixture by adding a drying agent. When drying is complete, the drying agent is removed through filtration or decantation. Rotary evaporation is used next to remove the solvent, leaving the isolated, crude, solid, neutral compound behind in the flask. Using rotary evaporation to isolate the neutral compound from the organic solvent is better than using simple evaporation or distillation. This is because it is faster due to the lower boiling point from the reduced pressure in the vessel, and because the rotation of the flask spreads the solution around the walls of the flask, increasing surface area for evaporation. Rotary evaporation is also conducted at a lower temperature than simple distillation, which is good for solutes which may not be stable at higher temperatures. When a solvent is removed, rotary evaporation allows for the reuse of this solvent, unlike simple evaporation.